Okay, characteristics of the photocyclodimerization. Solution state reactions takes place in N to pi star triplet excited state. Usually, cyclic alpha beta unsaturated carbonyl compounds participate in photocyclodimerization. And these are concerted addition at alpha beta unsaturation. Photoproducts are cyclobutane derivatives. Head-to-head joining and giving rise to cyclobutane derivatives, or head-to-tile joining giving rise to mixture of products. In polar solvents, if the concentration is more, then head-to-head products are major. In non-polar solvents, if the concentrations are low, then head-to-tile products are major. Photocyclodimerization generated by the triplet quencher. Sensitization by triplet photosensitizer such as acetophenone, benzophenone. At the time of dimerization, one molecule at the triplet state, other molecule at the ground state. Here is an example, cyclopentanone on irradiation gives a bicyclic compound, cyclobutano, cyclopentanone. I will go to the next slide. In the next slide, so here I'm taking an example, cyclohexanone on irradiation. It gives two kind of product, head-to-head joining addition product and head-to-tile joining addition product. Similarly, if we are looking at the stereochemistry, for smaller rings, cis will be the ring junction. Here also cis will be the ring junction. This also a cis ring junction. This also a cis ring junction. So for substituted cyclohexanone, also you can observe that a cis ring junction and cis ring junction, cis ring junction, cis ring junction. Only the difference head to head joining and head to tile joining forming a cyclobutane derivatives. I'm taking one more example, that is a substituted alpha beta unsaturated carbonyl compounds on irradiation gives one cis ring junction, here also cis ring junction, and this is about head to head joining. I will go to the next slide. In the next slide, I'm taking one more example. The compound is cyclomalic anhydride, succinic anhydride. Malic anhydride on irradiation gives a cis ring junction. This is a cis ring junction. And you know that benzophenone means what you call a quinone. This is the quinone, and dimerization will give you this product. Similarly, naphthoquinone and dimerization will give you this product. I will go to the next one. Next is I'm taking a six-membered ring cyclization one. Six-membered ring cyclization ones are giving a trans ring junction. This is the trans ring junction. This is the trans ring junction. That means alpha beta unsaturated six-membered one will give you the trans ring junction. This is also a six-membered one. So we'll give you the cis ring junction. This is again, but what is the difference between these two? Here, there is no quencher is used, but here a triplet quencher is used. Because of the triplet quencher, a cis product is obtained. I will go to the next slide. In the next slide, I'm taking one more example, a naturally occurring terpenoid. So this on irradiation, it will give you the two products. One is head-to-head joining, head-to-head cycloaddition one, and head-to-tile cycloaddition product. So here I'm taking one more example, what you call a six-membered ring with alpha beta unsaturated one. This on irradiation, it will give you head-to-head joining and head-to-tile joining one. I will take one more example. So here, photocycloadditions, A double bond B, C double bond D, this hand cycloaddition, that means 2 pi 2 pi cycloaddition forming a cyclobutane 1. So addition of alpha beta unsaturation of carbonyl compounds with the alkene or alkyne uh, in presence of light called photocycloaddition. So the obtained ones are bicyclic compounds. More particularly, here addition takes place only at the alkene, means unsaturated double bond, not the carbonyl. See here also the reaction takes place at the unsaturated double bond, not the carbonyl compound. Obtained ones are addition products. So let's look into the what are the characteristics of the photocycloadditions. Irradiation at the absorption wavelength of the carbonyl compound. 5 to 5 star triplet common excited state. Addition always at a beta unsaturation, at, not at the carbonyl function. At the addition carbonyl compound at excited state, olefin or alkyne at ground state. Reaction intermediates are 1,4 biradical intermediates. Before the formation of 1,4 biradical intermediate, carbonyl compound develops a temporary charge transfer complex with olefin, and this is called exciplex. If olefin is unsymmetrical, the reaction proceeds in such a way to produce stable 1,4 biradical intermediate. Initial carbon-carbon bonding at alpha position of the carbonyl compound in formation of 1,4 biradical intermediate. If there is a stereochemistry at a olefin, loss of stereochemistry in the resulting product, non-stereo specific. The products are cyclobutane derivatives, mixture of cis trans isomers in small size cyclocompound. Cis predominates in small size ring formation, and trans predominates in more than 6-membered cyclic compounds. So here I am taking cyclopentanol react with alkene, giving rise to two products. One is trans, another one is cis, but cis will be the major one because it's a small membered ring. Similarly, I'm taking one more example. Cyclohexanol on reaction with the alkane on irradiation gives cis and trans are the products, and the obtained one is major is the cis one in the case of this. Then cyclopentanone on reaction with okay. On reaction, it gives two products, 2 plus 2 cycloaddition, and this will be the major one. I will take one more example. Here, a cyclopentanone one, on irradiation, it will give you singlet, and this crosses the intersystem crossing, forming a triplet of the carbon, triplet of the alpha beta unsaturated compound and the ground state of the olefin. So here there will be a bond formation. This is called exciplex complex formation, charge transfer, and then product formation. Here, two kinds of, initially there will be a bond formation between this carbon and this carbon, and this carbon and this carbon. So this will give you the minor product, and this will give you the major product. I will go to the next slide. In the next slide, I'm taking in photocycloaddition, more nucleophilic olefin carbon preferentially develops bonding at alpha position. The resulting product is the major one. And here, here is the carbonyl compound. So this on reaction with the acetone, it's not a acetone, it's a olefin, and formed product are these two, and this will be the major one. So this on reaction with olefin, forming two products, this will be the major one. This on reaction with the electron withdrawing olefin, and this will be the major product. This on reaction with olefin this will be the major product. This and reaction with the olefin. Here, two products. This will be the major product. I will go to the next slide. Here I am taking the cyclopentanone and reaction with the electron withdrawing dienophile. So this HANT irradiation, it is possible to get totally there are eight four stereo four stereo isomers are possible. Four stereo isomers means 2 to the power of n, that is equal to 2 to the power of 4, that is equal to 16 isomers are possible. Here are the 8 plus 2. 8 plus 8, that will be 16 isomers. Then here I am taking cyclopentanone and reaction with alkyne will give you this product. Cyclopentanone and reaction with olefin give rise to cis ring junction, and this will be the major product. And here 2 plus 2 pi addition will give you the cis product one. When it comparing these two, it will be trans, and this will be cis reaction. This will be cis reaction. So this and reaction with the alpha beta unsaturated carbonyl compound, more particularly a double bond or olefin and irradiation, it will give you this product. And it is found that this will be the exocyclic double bond will be the major product compared to this one. This is also exocyclic, but the position is different. I will go to the next slide. Here I am taking few more examples. And what is that? There should be, you should be write a double bond here. A double bond means olefin, alpha beta unsaturated olefin react with the olefin, forming a product like this. And here you can observe that a double bond, alpha beta unsaturated double bond react with the olefin and forming a bicyclic compound. So here also reaction of alpha beta unsaturated double bond with the olefin, but this olefin is electron withdrawing one. So the bond formation between these two and the electron withdrawing groups here one will be the major product. Similarly, this also electron withdrawing group, there will be a 2 plus 2 cycloaddition forming these two product as the major product. I will go to the next slide. Okay. What I will do, I will stop at this stage and I will continue in the next class.